Hello, and welcome to my esports physics wave machine. I'm playing a game called People Playground, and I am simulating wave properties through this machine. Now, this here is a metronome, and it will control our wave as it goes up and down. It will control the time it takes for each wavelength to complete. So let's turn it on. So, as you can see, the amplitude here is measured, and we can, say we can count every time it passes it, and the amount of time it takes will be our period. So let's see, 1 and 2. So that was a wavelength in 2 seconds, right? So from this, we can, measure the wave. It's kind of hard to get wavelength in this since the line, doesn't change, but you still kind of get the idea of the properties of the wave. Now over here we have our digital transmitter that will take the wave's data and turn it into 1 and 0's data. So over here, you can see, here I need to move it down a little bit more. And as it hits each receptor, it is sending out either a 0 or a 1 signal. Now this is how we capture digital signals from waves. Now, continuing on, we have many, many properties of the waves. Let's see. Now, we can keep this going. Now over here we just have a mirror. This demonstrates a pretty simple understanding of reflection. Now, there are many, many different types of wave properties when they interact with different states of matter. This game is not really able to simulate this diffraction or necessarily refraction, but one thing it can simulate pretty good is the reflection and absorption as well. Now, here, I'm kind of mess with this a little bit, hold on. Now, if we connect a wire while this is at its lowest, and we just disconnect this, we set this so that it's a lot more power. We can also demonstrate absorption. Now this is going to be a little bit graphic, but that is absorption, and that is the energy from the laser, or wave in this case, being absorbed into that person. Alright, moving on, we can demonstrate many other wave properties in this game as well. Let me just get rid of this machine since we have gone through it. So another wave property, well, that one was transverse waves. Another wave property would be longitudinal, which is sound waves. Now, if we slow this down and we play this sound drum, you can see the oscillations in the air that longitudinal waves create. Now, this is very different from our previous wave because there's no up and down motion. It is only going through the air as an oscillation of back and forth sound waves. This medium, or this form of waves can only really travel through another medium, so it can't travel through space or nothingness. It needs actual something there to, interact with itself. Moving on, over here, we have a kind of demo of the Earth a little bit. And through this demo, we can demonstrate P and S waves. Now, let's get a laser over here. So, let's turn off slow motion as well. So, let's say that there's an earthquake, right? It's originating from this place right here. And we have waves going off in all directions. Now, the S waves are going to kind of, they're going to bounce off this thing in the middle. They're going to bounce off everything, but they're not going to be able to get through it. And I know that there's a lot of lasers here, but essentially the S waves are just going to bounce around the outer shell of the Earth. And this is because it doesn't have the amount of force to get through this core. And so that is why the S waves, they bounce back and up and up and back and all over the membrane of the Earth. Now, if we get rid of the core here, we can demonstrate also just how pressure waves work, which they go all the way through and they they can hit the Earth on the other side all the way without having to go around. So that's what makes pressure waves a lot more detectable. And so we detect these waves through the known properties of either the S waves bouncing on the outside, and we know what they look like, and the pressure waves bouncing all the way through. Thank you very much. I think this was the entirety of my presentation. Thank you very much. Goodbye.